Awesome. Well, I'm so pleased to be here with all of you. For me, it's 3 in the afternoon. I'm broadcasting in the US, and I think a lot of folks here are in Europe. So thank you so much for hopping in, and I'm excited about this new podcast. So I think it'll be, or broadcast, I think it'll be a lot of fun to keep attending the events. I see that there's a new one that was just announced, so looks really awesome. Okay, so I'm going to go ahead and show you, I'm going to share my screen. I'm going to show you what we're going to talk about today, and then I'm going to run through some slides, and then I'll do a demo. And I'll tackle your Q&A at the end. And so hello, everyone. So I see you all in the chat. Okay, so here we go. I'm going to share my screen. Oh, sorry, I have to, again, allow permission for Microsoft Edge. Later, can I do this later? Sorry, all right, well, let's see if I can, sorry guys. I may have to refresh the screen and come back, so let's see what happens. Oh, is it going? Okay, I swear. Okay, reboot. Here's what we're going to be looking at today. So we're going to be looking at this website and how I created it. What it is it is a TikTok trainer, and it allows you to pick your favorite TikTok dance, and then it will show you, it'll load this thing up and it'll show you a preview of it if you want to look at that. And then it'll allow you to compare your movements to the TikTok video. So we're going to talk about how we built this thing, and how it's built on top of PoseNet, which is this library. It's part of the TF.js models, and we'll go through all of that. But for now, I'll go ahead and just play these slides for you. So, okay, I hope everyone can hear me, and I hope everyone can see my screen. All right, so today we're going to talk about PoseDance, which is a TikTok trainer. And I'm guessing that a lot of you folks are on TikTok and enjoying the goofy little videos. I have been guiltily enjoying them for probably a lot more time than I should be spending on this sort of thing during the day. But it's really a lot of fun just to take your mind off some of the crazy stuff that's happening in the world today. So my name's Jen Looper. You can always find me online at Jen Looper on Twitter. I'm a cloud advocate lead at Microsoft. I'm on the academic team. It's the greatest team. Just kidding. It's a very nice team, and it's all about people who are learning, lifelong learners, kids in K-12 who are trying to learn computer science, or people who are trying to switch into this field of computer science, or people who are learning and becoming better developers. So we're all about the educators and the students. That's my team. So today's agenda, if you just want to go and take a look at the app, you can go to aka.ms/PoseDance, and you can go ahead and play. Log in, go ahead and register and log in and try to get a high score. I'm sure you can beat me, so give that a try. So today we're going to talk about what is TikTok. We're going to talk about what is PoseNet, what PoseNet is. Then we're going to dig a little bit deeper into the technologies behind the scenes, what's going on behind the scenes, because I'm always nervous when you take, a machine learning library and you just slap it into a web app and run it up a flagpole and see if anyone salutes, like we say in the US. I like to know what's going on behind the scenes and seeing if there's any problematic things that we need to know about. I'll talk about how I built PoseDance, and then we'll have a dance session. So I hope that you'll all stick around for that because it's very embarrassing. So here we go. Okay. All right, what is TikTok? Well, what is TikTok? TikTok is the greatest mobile app ever invented. Fun fact, it's actually an evolution of an app called Musical.ly, which was released, I would say 2 or 3 years ago, and it was for kids to make music videos. So it allowed you to upload your videos and kind of put music clips against it and create little music videos. It got kind of popular, and then it evolved into TikTok. And yes, it is a complete waste of time, but it's a very fun waste of time. It's actually, I find it kind of wholesome. If you tweak the algorithms a little bit and click on the things that you like, you'll find that, of course, they push videos at you that they think you will like. So there's a nice recommendation engine behind it, like with all social media. Mine is completely crammed right now with dogs and cats, craft projects, And for some reason, a lot of slime. There seems to be a lot of little things that people do with slime, and they're all over my TikTok. I don't know why. I think I clicked on the wrong thing. But yes, it's a total time waster. It's a little bit like Vine used to be. Vine was all about short videos. TikTok is, the videos are 60 minutes, 60 seconds in length, maximum, and you can clip together many videos to create those clips. And it's particularly famous for its dances. There are a lot of very almost semi-professional people who are dancing on TikTok, and they're creating dances. And what's interesting to watch is how the music industry is interfacing with these dancers now. Drake just released his Tootsie Slide dance, which was a remix of another song, and he was absolutely gearing for these people on TikTok to be creating a viral dance. So it's really kind of, in a way, influencing the music industry now. I think that's quite interesting. It could be worse, right? Other things could be influencing the music industry now, but here we are with TikTok. Pretty wholesome. There's a fun article at the bottom of this slide, which I'll share all these slides in a repo. It's on the Rolling Stone. There's someone who did kind of an expose of the culture behind Twitter, how I spent a week on Twitter and only lost like half of my life. So good fun. So that's what TikTok is. What about PoseNet? And what's the relationship? Well, PoseNet is a cool library released by Google, thanks Google, for pose detection in the browser, or there's also a TensorFlow Lite version of it, so you can do PoseNet in your Android and iOS apps, so that's really, really cool. But the one that we're going to use today uses TensorFlow.js in the back, so you can use it on the web. You can create web apps and build based on it, and it works really, really nicely. It's designed to be used with your webcam. You can also use it within a canvas. So if you import video and implant it into a canvas, embed it into a canvas, you can use it there, or it can be used with still pics. And this version of PoseNet can be used with one or more people. You can use it for just one person to detect the poses, or many, many people. I think it's interesting how it's being used for sports. If, for example, you're playing baseball, just to be all American, and you slide into first and you injure your ankle, well, maybe you have a video of that and you can see and you can analyze how, you know, your body positions were incorrect at that very moment. And maybe, you know, you could use these kind of skeleton diagrams to analyze how, you know, the proper way to position your body. So it's being used for that sort of thing. And all it really does is it gives you estimations of the position of 17 key body points. And you yourself have to create the skeleton on canvas. So all it's giving to you is an array of key points, and you have to figure out and design the little dots and then the little lines to make the skeleton yourself. So I'll show you how I did that. It's something that doesn't work right out of the box. You have to do that yourself. So PoseNet just gives you a little JSON object here, and it just gives you the XY position of what it thinks is the left eye, and it gives you a score. So I'm 99% sure that I'm looking at the left eye at position X and Y. So it's, you know, your Cartesian coordinates, and it's figuring out which are the positions that it's looking at of these 17 key points. And for every frame of a video, it'll send you another iteration of this JSON object. So it gives you a lot of data that you then are allowed to analyze on your own. Oops, sorry, wrong one. So let's dig a little bit deeper. So what's going on under the hood? PoseNet is built on top, stands on the shoulders of giants like all machine learning things do nowadays. It's built on top of Person Lab models. And Person Lab was a way of determining people's stances and actions in a video or photo. And it's built on this idea that we need to move away from doing top-down determination using bounding boxes, like in this image here, you know, figuring out, oh, here's a person and here's a person, and just draw one big box, which is useful, you know, for some tasks, but it could, you know, could be significantly improved by figuring out a bottoms-up approach, which is a box-free, fully convolutional determination predicting the relative position of those 17 key points, and it's measuring eye to eye, shoulder to shoulder. And so it's really, you know, moving away from this top-down box first to a bottom-up parts first concept. And it starts from the most confident detection and works up based on trained body poses. and it's using a pre-trained model to analyze what it thinks are appropriate body poses. There's a research paper here that I would direct your attention to, and it's very, very worth reading the research under the hood. So if we dig even deeper, we can talk a little bit about how PersonLab and PoseNet were built. So talking about PersonLab, so PersonLab training consists of 2 steps. So it detects the person and then it estimates the poses. And first it attempts to detect key points and then it groups them into person instances. So the network is trained in a supervised fashion, and it looks for 17 face and body parts using the COCO dataset, COCO dataset. It's the Common Objects in Context dataset. So it's a standard dataset that it's using, and it's grabbing the images of people out of that. And the first step is that it uses heat maps, which you can see here. It uses heat maps and short-range offset predictions to identify possible key points, what it thinks might be a possible key point. So it starts kind of rough. And then it uses Huff voting to determine the most precise placement of a key point, excuse me. So what is Huff voting? Huff voting is based on Huff transforms, and Huff transforms are a feature extraction technique used in image analysis and computer vision. So it's designed to find imperfect instances of objects within a certain class of shapes by a voting procedure. And this was actually invented in 1959 and trademarked, copyrighted in 1962, I believe. So it's interesting how machine learning and these libraries as they develop tend to be built on pretty old tech. We're just finding new ways to use these older algorithms and older feature extraction techniques. So from these votes, it's creating Huff arrays alongside mid-range offsets between determined key points to detect the human poses. So you can see we have the Huff voting and creating arrays, and then it's looking for short-range offsets. And then it's using the detections to create likely instances of individual people, using long-range offsets to group the person into segmented instances of each person in an image. So it's moving from kind of rough detection, figuring out via the voting where the short-range offsets are, and then it goes back and looks for mid-range offsets and figures out which part it's looking at is the shoulder and which is the hip. And all of these steps are using convolutional neural networks. That's interesting to note. And eventually it will create this tree-structured kinematic graph of a skeleton with those 17 key points. So it's really quite amazing tech. It's very impressive, especially when it's looking for multiple people in an image and determining which skeleton is associated to which person. I think it's really fascinating. I would also encourage you to take a look at this research paper, which is in the bottom of the screen. Okay, so from PersonLab, we moved to PoseNet. Like I said, PoseNet's this project of Google Creative Lab to run real-time pose estimation in the browser. And what it does is it abstracts away the complexities of the PersonLab model and creates something that we web developers can just use out of the box to a certain extent. So it encapsulates this functionality into easy-to-use methods that you can grab the key points and do things with them. There's an NPM package, so you can install it via NPM as part of TensorFlow models, the TensorFlow models GitHub. And in the browser, it accompanies TensorFlow.js, so you need to also have that installed. And using TensorFlow.js allows you to use these TensorFlow models in your browser. And fun fact, it does use fast, greedy decoding algorithm from the PersonLab paper to create these skeletons. And here's a Medium article at the bottom of the screen that you can check out. Lots of reading for you today. It's okay, we're all at home doing nothing, right? Great. Okay, so we have the technology. What are we gonna do with it? Let's build an app, right? So we're gonna use PoseNet to compare a dancer's movement to your own, comparing a TikTok video to your webcam output. Well, fortunately, so originally I thought, well, I'll just grab the embeds that TikTok provides. If you go to tiktok.com and check out the developer tab, it'll give you the embeds. And I use those on the front page, but you actually need to have a video embedded into a canvas so that you can use the canvas drawing API to draw the skeleton on top. So I wasn't able to use those embeds embedded into a canvas. So fortunately, and interestingly, I was surprised to find that on the mobile app, in a lot of the videos, there's a share button and you can download the video to your phone. So that was a bit of a surprise. So I could grab the videos that I needed and just post them into my web app. So I wanted to make sure to give proper attribution to the dancers, but then use their videos. So I went ahead and created the home page with all the embeds, and then I used the embedded videos on the second page. Before I go any farther, I wanted to just talk a little bit about some concerns that I started having when I was working on this project. And I was worried that the whole concept is potentially inherently ableist. What is ableism? Ableism is this idea that people are only properly abled when they have all of their faculties intact, right? So we're not paying attention to people who are handicapped, or people who are missing a limb, or people who are blind or have other issues that they're handling. Is it something that only would work for people who are completely abled? And it's interesting to see that PersonLab and PoseNet, it doesn't make any kind of judgments. It just measures what the key points that it finds. So if it doesn't happen to find an eye or like an arm, then it just wouldn't show those key points. It would just say that, you know, this key point doesn't exist. So it wouldn't return that as part of the JSON array that's being sent back to you. So that's interesting. The other thing we don't know is we do know that it's using the COCO data set to look at images of people, but we don't know exactly what parts of that data set it was looking at, or it was which parts it was used to build these models. So we don't know, you know, whether it looked at differently abled people. So it seems to me that there are a couple things we don't know about PoseNet that probably we should know to determine whether this the algorithm is ableist in its nature. But I think as long as we create the app that will have references towards people of different abilities, as long as we include those folks in our app, then I think we're in good hands. So if you're going to create an app that only semi-professional abled dancers could use, yes, that would be ableist. But if we make sure to create an inclusive app, then I think we don't worry too much about whether the thing is inherently ableist, because we know that PersonLab and PoseNet can handle missing elements or people who are in wheelchairs. And I'll show you a demo using a wheelchair dancer in a minute. So as long as you're careful, you can avoid any issues of ableism. Okay, so we've decided to build this app. We decided to put to rest these ideas that it might be inherently ableist. Let's talk about the way I went about building this thing. So there are some design considerations I needed to have. I needed to figure out the base architecture. I knew I wanted to use PoseNet, but I wasn't quite sure how. You know, you start from scratch and you're greenfielding an app. You have to figure out the best way to use this kind of NPM libraries. Needed to figure out how to handle my webcam, how to handle if the webcam is not present, because that's kind of not very fun if the webcam isn't present in this app. I needed to figure out how to make sure that these pretty heavy models load up properly before anything starts. So that's the first thing that I noticed, how heavy these models are, and the fact that I have to use two of them is interesting. I have to use one for the video and one for the webcam, so you have to load them up twice. So that just creates a pretty heavy website in and of itself. I needed to figure out how to build scoring to make that leaderboard, and how to use this thing on the back end. So I used Azure Functions, and I used a service called PlayFab. If you go visit playfab.com, you can take a look at, this is a very nice platform as a service for game development. And it works really well for the kind of things I tend to build, you know, fun gamified interfaces. And then I had a couple questions on where this was going to live and how I was going to deploy it. So let's talk about all those things. Okay, design and architecture. Well, I'm a Vue.js developer. I really enjoy writing Vue.js apps, so I went with the thing I'm most comfortable with, and went ahead and installed Vue, Vue Router, Vue Validate for validating the authentication forms that I needed to build, Vuex to save user state, Axios, which partners nicely with Vue, so it is your library that you're going to be using to query your API. And then I needed to install Bulma, which uses Sass for styling. Bulma is a nice way to create, you know, quick and easy layouts that are responsive. I wanted to then make sure that I installed the proper pieces of PoseNet. So first you have to install TF.js, which is TensorFlow.js, because PoseNet has a dependency on that. And then you can go ahead and grab your PoseNet model and install that as an NPM dependency. So those are this is kind of your recipe of the NPM pieces that you need. Okay, so using TikTok in your webcam, a side-by-side layout. This is kind of design, how the design kind of worked together. So I have a side-by-side layout analyzing the MP4 from TikTok with your webcam output on the other side. Like I said, I couldn't use my embeds. I had to use those downloaded MP4s so I could attach them to the canvas so that I could use the Canvas API to draw the skeleton. And I did a little play testing of this app. My daughter thought it was triggering. She thought it was unfair to immediately launch into, having your skeleton analyzed. She's like, we need a preview mode first. I want to see this thing, and then I'll go ahead and test my moves, because otherwise I'm going to get a terrible score. So actually, she's not a huge fan of this app. I think I need to make it more friendly for the kids so it doesn't upset them. But anyway, so I wanted to ensure this kind of preview ability, so you can look at the video, look at the skeleton without having the webcam kick in, and then have this as an extra ability within the app. So using PoseNet, boy, are these models big. And like I said, I have to load up 2 of them. You can watch the amount of JavaScript that comes along the pike. I had to load up 2, 1 per cam. So you got your video here and you got your webcam. You have to make sure to wait for the MP4 to load up, because these are also relatively big videos, some of them. And then make sure that your webcam is allowed and ready. So in preview mode, you want to allow it. I wanted to also encourage a login to save scores. So I created a little widget at the top, encouraging folks to, go ahead and log in, make sure your scores are saved, but not make that mandatory, of course. And then I needed to have a loader widget just running, because these things take so long to load up. I counted about 10 seconds on a slower Wi-Fi to get moving, and it like it says, 10,000 milliseconds, it's quite a lot to load when everything gets moving. So, this is not something we're gonna take to production and worry too much about. It's something fun to try, but just to let you know that these are heavy models if you want to use them in any kind of production situation. Okay, so when you're dealing with webcams and video, you want to make sure to be very comfortable with async await. So we're going to wait for the setup camera to be loaded, and then we're asynchronously going to mount everything else. So there's quite a lot in the mounted lifecycle hook. I'm referencing the TikTok video here. I'm setting up and enabling the reference to the webcam video. Have to set up 2 canvases to draw the key points and skeletons on. And I have to load up the models and handle the video events. So I detect the poses when it's playing and calculate the score when it's done. So that's a lot going on in the mounted lifecycle hook. So we're just gonna run that preloader and just wait. Just wait till everything is loaded up. So it does take a little time, and async is your friend. So for the posing, for each video, you're going to load your model, and then that model is going to start estimating the poses. So what I decided to do to get the score is to append each pose as its output by the model to an array for future scoring. And I drew the key points and skeletons using the estimated location of the key point, using, like I said, the Canvas API for that. And then you use request animation frame, that API, to detect the video keyframes. So each one of these is going to append a part to the scoring array. So it's quite a processor heavy kind of app. There's a lot going on for such a simple concept, but this is machine learning in the browser, at least in terms of detection. So, it's kind of magical. It's kind of a miracle that it works. Actually, it's a miracle that anything I build works, but here we are. Okay. Drawing the skeleton, so starting to sound like Halloween. Okay, so to draw the skeleton, like I said, you have to do it yourself. So you gather the adjacent key points and then draw dots and lines using the Canvas API. So for the dots, you use an API like begin path, an arc, and fill with a color for the dots. And then for the lines, you have begin path and move to the second, the second key point, create a line to that second key point and give it a nice stroke. You can also give it a different color. And since it's a DIY drawing, you can tweak that color. You can tweak the line width. I'm experimenting with this a little bit to see how another library works, which is hand poses. So PoseNet has both the skeletons and hand poses, and I'm tweaking just to see what I can do with the hand poses and figuring out the color and the line width, what looks best. For scoring, so like I mentioned, we gather the key points from the webcam and the video feed, and then I'm comparing the webcam points array to the video points array. So the system of truth is the video, and I'm comparing the webcam points array and where they fall on their X and Y score to the video points. This means that when you're watching one of these dancers, you need to get in the frame enough so that the video can see the points in your body that are to be analyzed. And I'm just basically finding the difference between the webcam points and the video points. And I tend to get very negative scores. And this is what my daughter didn't like. So it's like, geez, I'm doing my best and I'm getting a minus 400. It's terrible. So maybe there's other ways to score. I have gotten into positive territory if the dance is very simple. So we'll see what we can do. But scoring is a little bit of an art, figuring out, what's the best way to score. And then I'm sending some data back to the PlayFab backend. So I used PlayFab as this mobile platform as a service backend. It is great for games. We've used it for several projects. You can put all of your calls in an API folder and then use Azure Functions to just call PlayFab. So that's a nice clean way to use the NPM package from PlayFab and to go ahead and use some of the APIs like update player statistics, which is how I created the leaderboard. So it's a nice and tidy little package that you can use. I recommend it for all of your kind of lightweight game development and gamified interfaces. PlayFab is super, and it's free for indies. So here's the leaderboard. This is getting the leaderboard, actually. So it creates a public leaderboard of all the players if they have an account. You need your title's secret key. So you need to somehow save that in your environment variables. And you can do that in the service that I deployed it to. I'll show you in a second. And then build the leaderboard via the PlayFab API and then use Axios to display it. So I'm just, using this little Azure function to display the leaderboard in the link at the top of my app. Okay, and then deployment. This is exciting, folks. So where is this app going to live? Well, guess what? We have a new and hot service at Microsoft called Azure Static Web Apps. And I was so happy when this thing came out because I really, really needed it because I do so many of these kind of apps and I really want a clean and fast way within Microsoft to host them. These are free. You can go ahead and try them now. And it's a really nice workflow because when you just deploy your app on an Azure Static Web App, a little folder is created for you in your GitHub, and it has a deployment script that Azure Static Web Apps picks up. So then it's handled in the deployment situation is handled in your GitHub Actions, and you can watch the thing building or failing. If it fails, there's a button to try to rebuild again. It works really nicely. It's a nice continuous integration GitHub action-based workflow. I love it. And it works really well for these type of apps for spas, which is what I built here, single page applications, for VuePress static apps, for Gatsby, and we've got some really great documentation that you can check out. If you're curious, try AKAMS, try static web apps, and give it a spin. It works really well. I was so happy. Oh my gosh, it's time to demo this thing. Okay, here's where the embarrassment starts. Okay, I'll just close the slides and I think I saved something, so I'll save that. Okay, let me go back to PoseDance. So I'm gonna go ahead and reload this. And let's pick a dance that's not too hard. All of you TikTok dancers, you know that you can't run through TikTok and look up anyone dancing and not come across Charli D'Amelio. I like this girl, Gabby B. If you're looking for someone who dances Savage really well, which is the big TikTok song right now, check out Kiki. If you're interested in Addison Rae, she's a very good dancer. The original Renegade dance was done by Jalaya, so I have her here. That is just too difficult for me. It's all over the place. If you've got a lot of space to maneuver, you could try the Tootsie Slide. I don't know, it's like a Tootsie Slide. The Tootsie Slide, that kind of, you need a little bit of extra space and you need to be upright. Here I've got a couple of differently abled dancers. I'm going to go ahead and visit this guy because I know this dance. I know I can do it. Kind of. Okay, so here's that loader. It's already ready. Wow, that was fast. Probably because I preloaded it. So I could click preview and we would be able to preview the dance. But I'll go ahead and click play. Here we go. Okay, where's my score? My score. Oh, what a disaster. Okay. Possibly I wasn't far enough back and possibly I was out of the frame. I think my webcam was pushed over a little bit. So that's my excuse. What's yours? Okay, everyone log in, hit the leaderboard, and let's get those high scores. I think I'm logged in as, I think I'm logged in as anonymous right now. Am I logged in? I might not even be logged in. Anyway, so it'll just show, if you're logged in, it will just show your highest score that you get. So everyone go ahead, visit the PoseDance app and aka ms/PoseDance and check it out and show me your high scores and like and tweet because we're supposed to do that. Okay, I'll go back now to the conference. That is what I wanted to show you. And why don't I go ahead and I like the chat. I can start answering chats. I'll stop sharing my screen because we'll get infinity. So that is what I wanted to show you today. And I know that it's a very exciting moment in everyone's life when you can create useless junk and learn something at the same time. So it's good fun. So I'm happy to take a look at the Q&A. Okay, great question. Here's the first question. I'll just read them out. So what is the size of the PoseNet model? I'd have to look, but it's several megs. I believe once it's loaded, you could use it in offline mode because the models are loaded up for you. It's not making API calls, so it's used in the browser. So you should be able to use this in offline mode. So yeah, then at that point you could have that, go offline and keep using it. I haven't tried it. There is also a TensorFlow Lite version of PoseNet that would work better for mobile. People have asked me if I could go ahead and use this thing on mobile. I wouldn't burn my iPhone to pieces. So I would say go ahead and use TensorFlow Lite on mobile and just keep this on desktop. Is it possible to use in a progressive web app? If you could enable the offline mode, absolutely. Yeah, and I feel like I should try that and give it a shot because I'm pretty sure it will work. Once the model is in place, then you can do inference against it as much as you like. TensorFlow packed in an Electron app. Probably. You might need to use TensorFlow Lite, the TensorFlow Lite version for that. I think so. I'm not sure. Quota supported browsers with PoseNet. It would be cross-browser compliant. It works, I know for sure, with Firefox, Chrome, and Edge. The problem you might get into with older browsers is whatever fancy stuff you do with the Canvas API. That's where you're going to find the problems because all this is doing, it's not a browser technology. It's just, pushing these keyframes at you. So whatever you do on top of that is where you're going to have issues cross-browser. Quotas of Azure Static Web Apps. In terms of the free tier, I'm guessing, I need to look at the pricing for you. I believe that for the moment we're keeping everything free, and I can come back to you with actual pricing on that. This is all in preview. Azure Static Web Apps are in preview mode. So what we're looking for is actually for as many people to try them as possible, and for you to give us product feedback. So there's that. Is TensorFlow based on WASM? Nope. It is a machine learning library that is built by Google and maintained by Google. I think it's built in C#. And then the TensorFlow.js piece is built on top of that, and it's deploying the APIs, but for use in JavaScript apps. The exact scoring function is in GitHub. If you want to take a look at it, it's pretty hideous. What I did is I took each element and I determined for each keyframe the difference between all of the different key points. So every time the left eye diverged from the left eye in the video, let me say it again. Every time the left eye in the webcam diverged from the left eye in the video, I took points off. So I was really trying to show how you need to align your body exactly with the webcam. Great question. Do you need some ML knowledge to develop this kind of application? I don't think so. I just always find it useful to have a good idea what's going on with the models and how they're built, just so that we can determine that there isn't too much or any, if possible, bias in the way they're constructed. And the nice thing about Google is that they have open source TensorFlow. They're very open about how they build their models. Like they tell, like, we built this thing using this particular data set. Here's the data set, go look at it. That's always really useful to know. I really like how a lot of machine learning libraries are being built in the open now. So that is helpful. And then in terms of actually building an app using something like PoseNet, I don't think you need that much machine learning knowledge, actually. I mean, it's just for your own personal interest, you know, if you like that sort of thing, because you're using things that are pre-trained. You're using a pre-trained model and just using it within a web app. If you wanted to do something like create a custom model that you're training on your own data, then you need a bit more knowledge. So that I like to do that myself. I created, you know, very custom data sets. Actually, you all should love this. I created it on cheese. So I could determine types of cheese, which is a very specific use case for machine learning that you're not going to find this model out of the box. So if you want to train your own custom model, then you need a little bit of understanding of machine learning. Could you say with PoseNet if you're a good dancer? Absolutely, I think so. So I would think that if you did this thing properly, you could perhaps have a video of a ballet teacher, you know, showing exactly the positions that you need, you know, first, second, third, fourth position in ballet. And then you could have kids, you know, align their body exactly with the dancer and get a score. I also think that it would be really useful for yoga teachers. If people are having trouble aligning their body properly to the yogi, then you could, you know, you could actually have maybe notifications saying, you know, your hip bone is not in the right position, you know, move it over to the left. That would be a really useful thing, actually. Even like personal trainers, that kind of thing. Can you determine a kind of difficulty of the dance? Difficulty of a dance. That's an interesting question, because what does it mean to be difficult? What's difficult for some people is not difficult for others. I would say that you would have to have a baseline saying, if you would run it through PoseNet saying that there are X number of movements of the body, and the more movements, the more difficult the video. That would be like a baseline, and you could create a scoring off of that. That would be probably the way I would go about it. That's a good idea. I like that. This is a level 10, you know, don't try it. 3D model animation, no, I don't believe it supports 3D, but you can use it on real videos. I don't know, could it be used on a 3D model? Maybe it could, because it would be able to, if you could embed that into a canvas, you could possibly enable it for something that the algorithm can determine that it's a person. So maybe actually we should try this and see. Try it on a video game to get it a shot. Give it a shot. I love the idea of PoseNet with cats. It's actually trained on people, but now I'm really curious and I want to see if my cat will dance properly. So I don't know. Maybe. Any possibility to extend and compete with another person on the same camera? Yeah, good idea, but you'd have to have yet another PoseNet model to be analyzing the second webcam. So you would have to have you know, your baseline video being analyzed and then the two people, and I don't know, it would be so heavy. It would be scary. You'd have to have something running in the cloud to power the machine. But sure, anything's possible, but it might be a bit slow. Oh, Aurélien, you're asking all the good questions. Any other application ideas to develop? Yes, indeed. So I'll tell you my next project. So PoseNet is used for people, but they have another project called, I think it's called Hand Poses. And it can take one hand and it can determine the different poses of the hand joints that it's seeing. So it'll give you key points for the wrist to the knuckle, and then 1 and 2 and 3 points, I believe, on each finger, or maybe just 2 points on each finger. So I'm creating something, you're gonna love it. I'm creating something called ombromanie. So it is, you know, the people who do the hand shadows, and it's really cool. Like you can have, you know, the bunnies, you know, bunnies hopping. I'm creating a way for like grandparents to create a story with hand shadows and send them to their grandkids, something like that. I think that would be really, really fun. And it's going to be this kind of website with this kind of Victorian look and feel. So that's my next project. As soon as I get done with the TikTok stuff, I'm going to be starting working on ombromanie. Yes, PoseNet can detect a pose on an image. You don't have to have it as part of a video. Very useful for images, and it would be a lot faster with just a static image. It can look at multiple people or a single person on an image. Yeah. I think you could absolutely use PoseNet for yoga poses. I kind of want to try this and embed a video and see what it picks up. I think it's a great idea, especially we're still somewhat in lockdown and the gyms are closed, that you could have, you know, yoga classes. My daughter thought that this was a huge missed opportunity for, you know, my next $1 million startup, you know, that you could create a yoga trainer and people would be able to figure out, oh, good, to figure out the yoga poses. Absolutely. Great use case. It's working on 1vs1 right now, I guess. Could it be used on multiplayer mode, like a group versus group mode? Oh, I see. One-on-one, yes. Yes, all you have to do in PoseNet is to say that I want to use the multi-person mode. And yeah, but the scoring would be a nightmare. So I don't even know how to go about scoring such a thing. But yeah, you could have, let's see, if you had a video or a webcam of a bunch of people here compared to something that's going on over here. You could have a knockdown, drag out, rock, paper, scissors tournament. That would be fun, right? Something like that. Could it be used to learn deaf people's language? Yes, not PoseNet, but hand poses, absolutely. The only problem with hand poses is can only be used for one hand right now. So I think fingerspelling, like Jenny, that's my name in fingerspelling, that's done with one hand, but most American Sign Language, at least I'm pretty sure, is with both hands. And that, I hope they're gonna create this. I need it for my project. So really, really a great use case and something that we should totally try for as soon as they give the double-handed detection. Limits of PoseNet in terms of detection. The limit are just that it's gathering the 17 key points. So PoseNet itself doesn't, for example, give the hand poses or the feet poses. It just shows you where there's an ankle and where there's a wrist. So that maybe Maybe that's why they developed the hand pose model to show, because this is actually a pretty complicated thing, and there's a lot of things going on with your hand. So that's probably why they decided to split the model and go from there. Send data to train your own data with TensorFlow.js. Yes, there is a good tutorial on how to do that in Google Code Labs, I believe, called The Teachable Machine. And you can create an app in your browser that will train a machine learning model. Now, I personally think that using a browser to train on data is a little much for a browser, and I think that it's not very scalable towards something a company would necessarily need. Maybe it's something a company would need, but my personal preference is to train your machine learning models in Python and have those exported as a TensorFlow or as a TensorFlow.js, TensorFlow Lite or standard TensorFlow model. Use those in your web apps or your mobile apps as is. I don't love training in the browser. I like doing inference in the browser. So that's just my personal preference, but technically, absolutely, you can train in the browser if you so choose. Check out Google Code Labs. It's really a great resource to get educated in this sort of thing. Good fun. Okay, so 3D capability for the same model, say with 2 cameras for a single person. Ooh. I don't think the results are going to be great. It's really looking for one camera, one canvas to draw on, and one single or multiple persons. But what I was thinking is if you had a 3D image of a person, then you could display those key points if you could import that 3D image into a canvas and draw on top of it. I've never tried this. It's totally worth it though. Give it a shot. I hope that answers your question. I don't do too much with 3D. Other ideas with TensorFlow. Oh boy, I'm like an idea machine. Lots of fun things that you can do with TensorFlow. I love training custom models. TensorFlow, Google has another great, here I am at Microsoft and I'm touting Google, but anyway, Google has a really cool product called the Coral Board. The Coral Board, it allows you to do inference in an IoT device. So I trained a custom TensorFlow model on songbirds using a data set from Cornell Ornithology Labs, and I put the camera that is attached to the Coral Board on my window next to the bird feeder, and I was counting how many birds and figuring out which birds are coming to the bird feeder. That's a really cool thing. Works brilliantly on edge devices. So TensorFlow Lite on edge devices, wonderful and exciting use cases. There's all kinds of other applications with TensorFlow. It's a really powerful library. I use it a lot. And the great thing about TensorFlow is that it has this nice export capability with TensorFlow.js and TensorFlow Lite for web apps and for mobile apps. So there's just a lot of great applications. PoseNet in the medical world, indeed. I don't know why, but this just jumped into my mind. After the Boston bombing, we had a lot of people with amputations, and I wonder if you could use these models to analyze their progress as they relearn how to walk. So maybe for injured people, for paraplegic people, for people who are trying to get their body realigned, for chiropractic, or to make yourself sit upright instead of slouching all the time like I do, to make yourself sit upright, that would be another good application. For people who are worried about, scoliosis, it would be interesting to take those shoulder measurements and see, if you're degrading over time. I think there's just a lot of really great medical applications. GPU of the client to process the data. This is something another person asked in another session I did with this. I don't see a lot of information in the PoseNet archives or in their repo about the use of the GPU. I need to better understand this. Let me do a little research on this one because I don't want to give you the wrong answer. But it would be something to check out. I'm gonna make a note of that, and I'll show you. I'll I'll tweet out the answer on my repo. How about that? Is it possible to detect hand shape with PoseNet to build a sign language translator? Yes, somebody else was asking about this. Like I was mentioning, the hand PoseNet library is just for one hand right now. So I don't know much about American Sign Language, and I know French Sign Language is different, but I feel like sign language is the whole body. So it would only be able to help you insofar as sign language is used for fingerspelling with one hand. I guess I would go as far as that. For everything else where you really need, where the hand is located as it's interfacing with the body, you need almost something even better than PoseNet. You need PoseNet plus the hand poses all together. That hasn't been developed, but for fingerspelling, that would work, I think, as long as it's just one hand. Maybe we can push Google to give us a multi-hand model soon. Possible to use this in production for customer apps in the browser. It's usable now. You can go ahead and use this. Just be aware that they're heavy. They ought to, maybe we can work with the TensorFlow folks to make them a little bit lighter weight. But as long as you're okay with having a relatively heavy web app, you can use them in production now. So I think that, go ahead and use them and show me what you build. I'm excited. Any other questions I can help you with? I'm going to find out the answer to that GPU question because that's the second time. TensorFlow is using one or many neural networks to work. So TensorFlow is based on convolutional neural networks, and that's what it's using behind the scenes, which is a lot of neurons. To learn more about TensorFlow, to learn more about machine learning, take the Coursera course by Andrew Ng, NG. To learn more about TensorFlow, go to Google Code Labs and take their little tutorials. Those are really good. Strongly recommend. Go forth and build.